How's it going, everybody? In this video, we're going to take a look at our first technical topic inside of the ENCOR and ENARSI series by diving into layer 2. So focusing specifically on things like VLANs and trunking and spanning tree protocol and things like that. So we're going to dive right into the meat and taters. So let's go ahead and get started with this bad boy. So what I'm going to do real quick is we're going to just break down some basic theory to how VLANs work and how they interact in the environment that we have. So for those of you that are familiar with layer 2 networking and layer 3 networking and things like that, then this should be really nothing new to you, right? This should be pretty straightforward basic stuff. Now, when we talk about this operation, the VLAN is going to be the very first thing that we need to be aware of. And what's a VLAN? Well, a VLAN is it's also referred to as a subnet. And what's a subnet? Well, this is a subnet right here. 10.100.1.0/24. What does that mean? Well, basically it gives us 256 IPs to leverage to do whatever we need to. So do I need 256 IPs? No, I really only need 3. One here, and one here. But the reality of it is we can leverage as many as 256 for /24. But the reality of it is /24s are just easy to subnet. That's why you see /24s on different multiple links on the topology, because they're easy to subnet, right? I don't have to sit there and think about the subnetting. I'm not doing anything like /24 or /28 or /20. We'll talk about those things more in detail when we get into things like summarization and aggregation. But right now, we're not really focusing on the aspect of, hey, we want to roll out a bunch of design and stuff like that. Not really the purpose of this video. But the IP addressing aspect of it does correlate to the subnet. But here's the cool thing about that. Even though a VLAN is a subnet and a subnet is a VLAN, that doesn't mean they're one for one, and they have to be one for one. What do I mean by that? Well, if you have VLAN 1, right, and VLAN 1 is the default VLAN on any Cisco switch that's out there. Well, if I have VLAN 1, normally that's going to associate to a particular IP address. In this case here, I've got 10.100.1.0/24. But does that mean that I can't use another subnet inside of the same VLAN? No, it does not. It goes against the common way that most technical instructors are going to lay out how VLANs work, because the simplicity aspect of it is, if you have a VLAN, you have to tie that to a subnet. But that doesn't mean you're limited to just one subnet. Because remember, a VLAN is nothing more than a broadcast domain, right? A broadcast domain enables communication between all the endpoints within inside of that broadcast domain. That doesn't mean it's going to limit it down to a single subnet. You could have 50 subnets, right? It does not make much of a difference. So that means I can have 10.61.22.0/24 here working as well. It's completely 100% fine. The cool thing about it is when I do stuff like that, it gives me latitude to allow multiple subnets to work. Now, do I recommend that you do that? No, I really don't. But the point being is you can have a single VLAN deployed on your switch, and you can plug in, say for example, let's take this switch right here. Well, if I was to add another device off here, let's say we've got PC1, right? We got PC1. Well, PC1 and iOS 16 were placed inside of VLAN 1 here, and then I was to take PC2 and let's say PC3 and plug them into switch 3 as well, or the switch. Would they be able to communicate with each other all in the same subnet? Sure they would. But if I was to change the IP addresses, let's say I was to take iOS 16 and PC1 and configure it with one subnet. So let's say 10.1.16.0 for example. So if we gave 10.1.16.0/24, and then PC2 and 3 were in 10.2.3.0/24 inside of VLAN 1. Would PC2 and PC3 be able to talk to each other? 100% they would, because they're in the same subnet. What about router 1 or router 16 and PC 1? Would they be able to communicate with each other? Sure, same subnet, right? But would communication between router 16 and PC 2 work? No, it would not. Why wouldn't it? Well, because they're in the same VLAN, right? They're in the same broadcast domain. Why wouldn't they be able to talk to each other? Well, because of the fact that they're two different subnets, it means that they won't be able to communicate with each other. So whenever I want to communicate, so I being a PC or an endpoint want to communicate with another device or another endpoint on the network, I could be in the same broadcast domain. Yes, that is 100% plausible. Do I recommend it? No, but it can be done. In the event that that this is the situation that you're in, how do I differentiate me from somebody else, right? I'm 10.1.16.1 and you're 10.2.3.2. How does the endpoints not communicate with each other? And the simple fact that comes into play here is the subnet mask. The subnet mask is going to be the governing point that determines who can talk to who. So when you look at 10.100.1.0/24 and then you look at 10.61.22.0/24, they're not the same subnet, right? The governing factor, again, is the subnet mask. What ends up happening is when 10.100.1 looks at 10.61.22 and they compare notes with each other, they do what they call a binary ANDing. And they say, okay, how many bits am I in common with this other IP address? And in this case here, you have 10 dot here, okay, 10 dot down below here, right? So far, so good. But when they go into the second octet and they start comparing, okay, how many binary bits are turned on to get the value of 100? Well, whatever that comes out to be. And then it compares it with whatever you're trying to reach, 61. Well, 100 and 61 are not the same number, right? They're two different numbers, which means your binary ANDing would come out to a different value. If the binary ANDing was 10.101 and 10.101, then it would be it would line up and you'd be able to communicate with one another. But because of the fact that you're not 10.101, you're 10.61.22, your binary ANDing, your how many bits do you match on, doesn't apply, or that applies, and that restricts the communication. So even though you can have two subnets sitting inside of the same VLAN, you can't communicate cross subnet. If I want to be able to do inter VLAN or inter subnets, more specifically, not inter VLAN, inter subnet communication, I need to go up to a routed point of the network, whether that's a layer 3 switch, a router, a firewall. Doesn't make much of a difference as long as it's routing between the subnets. Now we have this term called inter-VLAN routing, right? So a router on a stick, layer 3 switch, whichever direction you want to go gets the job done, right? The point being is when we talk about communication between the two, you're not technically routing between VLANs, even though that's what we call it. If you read the books and the official cert guides and stuff like that, they refer to it as inter-VLAN routing. But the reality of it is they're limiting down a one VLAN to one subnet. So a VLAN could be a /24, or a VLAN could be a /22, or a VLAN could be a /29. By doing that, that basically says, okay, if we're going to limit a VLAN down to a single subnet, then the VLAN to subnet mapping is a one-for-one mapping. We don't have one VLAN with multiple subnets sitting inside of it. That basically allows the inter-VLAN routing paradigm to exist. But if we have multiple subnets, then you're not going to be able to do inter-VLAN routing. You're going to rely on inter-subnet routing. So in order for 10.101 and 10.61.22 to communicate back and forth with each other, they need to go to a layer 3 device to pull that off. Is that doable? It is, but it still doesn't make sense to put both subnets in the same VLAN, because you're going to be inadvertently exposing one subnet to the other when you might have two subnets that should not be able to cross communicate with each other. So even though I just said binary ANDing would not allow them to communicate with one another, I'm sure there's some people out there that would figure out a way around that. And would allow the communication. So point being is, when you're deploying VLANs and you're deploying subnets and you're trying to do the design work behind the scenes, one VLAN, one subnet, leave it a one-to-one mapping. That's going to make your job a whole lot easier long term. So now that we've talked about that, let's dive into a little bit more of the cool parts. Let's take a look at a little bit of the labbing. So one of the first things that I want to do is we're going to go ahead and take a look at this from, I think I had the wrong, maybe it's this one. Nope, that's not it either. One second while I find this. There we are. Okay, here we go. So I'm going to bring this guy over. So we have iOS 16, I have the couple switches, and then I have XR23. So basically just these boxes over here. So if I want to connect, or if I want to communicate between router 16 and router 17 and XR23, what is the minimum configuration that I need to have in play? Exactly, I need to configure IP addresses on those interfaces. Because what's going to happen with the switches out of the gate? Are they going to pass traffic between the switches? That's a common question I get. Like, no, they can't because they're not configured as trunk links. But au contraire, if I don't have any VLANs created and I'm using VLAN 1, then it doesn't matter. Because VLAN 1 automatically propagates the information between switches by default. So I don't have to worry about that. Where if I'm dealing with any other VLAN, I'm going to have to go out and create sub-interfaces on the routers in order for that to communicate, or put trunk links between the switches. There's a couple different ways of pulling that off. So let's go ahead and actually take a look at this. I'm going to look at router 16 and, whoops, I meant to say iOS 16. Let's go ahead and type in hostname is going to be iOS 16, and then interface gig 0/0. I'm going to type in 10.100.1.16/24. I'm going to go ahead and no shut that, and I'm going to give that a second to work on its thing. I'm going to come over here to router 17. Host name is going to be iOS 17. Interface gig 0/0. IP address of 10.100.1.17/24. I'm going to no shut that guy. And then I'm going to come over here to XR23. I'm going to go ahead and log in Cisco. Go to global config. Host name is going to be XR23. And then I'm going to go to interface gig 0/0/0/0. IP address of 10.100.1.23/24. No shut and commit. Okay, that's going to bring that interface online, which is what I want. Okay, so now that I've got that going on for me, I'm going to come over here to switch 34. I'm going to come in here, I'm going to do a show MAC address table dynamic. Right, so I see some stuff being learned on gig 00. I see something being learned. If I look at some of these other ports, I see stuff being learned back and forth. So let's look at something that happens here. So I'm actually going to go ahead and I'm going to right click on 16. I'm going to go to capture on gig 0/0. Now this I might have to, I'm going to have to make a quick adjustment. So if you get an error like this, if you capture on gig 00 and you open this up and you get this error right here, it can't actually SSH into the device to pull the connection over. The simple way to fix this is to actually open up PuTTY and simply come over here and type in 10.255.1.130 or whatever it is, whatever IP address has been given to your Eve server. Log in as SSH, and then when you get this guy right here, which says that the security breach, there's been a potential security breach, all you have to do when you're at this point is just close it, and then come back over here, right click, capture gig 00, open this up, and then you're going to get the connection will be opened up, and we're going to see communication happening back and forth. So what I'm going to do is I'm going to bring this guy over here, shorten it up just a little bit, and I'm going to go ahead and pull up the command line, and I'm going to bring this guy down just a little bit, and on iOS 16 I'm going to come over here, I'm going to do a ping to 10.100.1.17. So we get an ARP that goes out, right? If we look at ARP or ICMP, we're going to see communication going back and forth. So what we ended up seeing here was we sent out a broadcast packet to the broadcast address in the IPv4 header, right, or in the layer 2 header. We sent broadcast to the destination saying we don't know what the MAC address is of 10.100.17, and we need to know. So when you find out, go ahead and tell 10.100.116. What ends up happening is, because he responds, 10.100.117 says, okay, I have the MAC address of 11, basically is what this comes back with. That goes back, and then all of a sudden you can see the ICMP going back and forth. So this very first dot that you see show up here that pops up is actually the ARP message, right? But then when you come down here to the rest of them, these are all pings going back and forth. If I do the same thing to 23, that's going to apply. So I do that, it's going to go out there and look for it. It finds the ARP message, and then the ping goes back and forth, which is what we wanted to have happen, right? So all good, all good stuff. So in the case like this is the type of stuff that we're looking for to have an impact on. So this means that we're communicating back and forth. But here's the funny part. If we come back over here and we hit the up arrow, right, with the same amount of information as we had before. If we do a show VLAN brief, guess what? We only have one VLAN created. We have VLAN 1. So because we only have one VLAN, we are limited to just one VLAN. But what happens if I wanted to take and add a VLAN or do something with it beyond that? Well, I could, but that would require me to do additional things. Like if I wanted communication to happen between router 17 and router 16, for example, I would, and then needs to jump between the switches, I would need to configure the connection between switch 34, 35, and 36. So these connections right here in the middle would need to be configured as trunk links, so to allow the tagging effect to take place. So that's basically where that comes into play. So that is the basics to VLANs. Now you're like, well, you haven't actually created a VLAN, Rob, and you're right, I haven't. And the reason why I haven't is, in order for me to create a VLAN and then apply it to a port, which we're going to go ahead and do, in order for that communication to happen between the switches, I need to have a trunk link configure, which we'll talk about in the next video. But for right now, I'm going to go ahead and I'm going to configure a VLAN on switch 34. Go up here and type in host name is going to be switch 34. And then I'm going to create VLAN, let's say we create VLAN 10. Okay, let's create VLAN 100. And then underneath here, we're going to give it a name of VLAN 100. And exit out. That brief pause you just saw there was the VLAN being created. Next thing I'm going to go do is I'm going to apply VLAN 100 to interface gig 0/0. Type in switch port, access VLAN 100, switch port mode of access. So now that that's been applied, I can do show VLAN brief. And we can see that gig 00 is now sitting inside of VLAN 100, which is what the expected result. Okay. Now that I have that in play, the next step for me to go do beyond this would be to go create trunk links between the switches. So I'll take care of that in the next video because there's going to be a couple different variations that we take a look at. But this is basically where this comes into play. We need to know how to create a VLAN and apply it to a port. So that's one of the main things that comes into play here. As long as I wanted to make sure that you understood that having a VLAN created does not mean you're limited to just a single subnet, but that is the de facto standard. One VLAN equals one subnet. So what I can do now is I can actually go ahead and type in interface VLAN 100, right? And what's going to end up happening is you can see the line protocol goes down, right? Because I have to no shut the interface, because right now, if you look at the interface config, VLAN 100 is actually down. So if I was to just type in no shut, give that a couple seconds, it'll come online, right? Perfect, right? So it's online. If I was to do ping 10.100.1.16, I should be able to ping Oh, I need to give it an IP address. So IP address is going to be 10.100.1. Let's say 34/24 subnet. Do show IP interface brief. All of a sudden, you see this little pop-up right here. We get a gratuitous ARP, which means that switch 34 comes online, and then it announces itself to the network. Now, if I come back up here and do the same ping again, I should see an ARP go out, and then the ping replies, right? But here's the kicker. If I go to interface VLAN, or if I go to interface gig 0/0, and I type in switch port access VLAN 1, once that gets moved back to VLAN 1, what should end up happening is the SVI on this particular device, so do show IP interface brief, do show VLAN brief, the SVI will eventually go down. And it'll go down. It'll take some time. There's going to be carrier sense that's going to have to kick into play. It's going to have to detect the VLAN is no longer there and things like that. But once that process happens, in order for an SVI to be online, the VLAN has to be enabled on a port, right? So that's basically where that comes into play. But an SVI, an interface VLAN, and a VLAN are two different things, right? An interface VLAN allows an IP address to be applied to a VLAN interface to allow that particular VLAN to have an egress point off the network to something else, whatever that might be. And oftentimes an SVI, or a switch virtual interface, is going to be a default gateway. So if you wanted switch 34 to be your default gateway for a particular subnet, that capability is available to us in this particular capacity. So what I'm going to do is I'm actually going to go ahead and show you that if you go to interface VLAN 100 and you shut this port down, give that a couple seconds to respond, and then I'm going to no shut it. The line protocol should not come up because there is no and you notice how it says the interface VLAN is changed it down. So if I do show IP interface brief, it says down. And that's because there are no interfaces inside of VLAN 100. No interfaces on the switch are applied to VLAN 100, so there's no interfaces that are up. So, but if I go to interface gig 0/0 and I type in switch port access VLAN 100, switch port mode of access, as soon as that flips over and it's applied, then the SPI should come online. Now I don't know how fast the carrier sense is going to be here, so do show VLAN brief. It's applied. It's taking longer than it should though. I might have to get rid of the VLAN. So if I type in no VLAN 100, and interface gig 0/0. Actually, let's do show run interface gig 0/0. So let's actually come over here and type in default interface gig 0/0. So now it's been applied to the port. So now it should be back in VLAN 1. And there's the line protocol on gig 0/0 goes down, right? And if I do show run interface gig 0/0, it's down. Do show IP interface brief. If I was to, now it's acting weird. If I was to go and create the VLAN, so create VLAN 100, name it VLAN 100, and then exit out, give that a couple seconds. Do show VLAN brief, and then go to interface gig 0/0, type in switch port access VLAN 100, switch port mode of access. That should bring the SPI up pretty quick. It may be a little, if you were to do this on a physical switch, you'd have a different reaction because there's carrier sense, there'd be interfaces go down. You're getting kind of a virtual switch effect here where normally this stuff would not be happening. So if I look at the do show IP interface brief, the interface is still down. If I was to go to interface VLAN 100, if I was to shut it, and then as soon as I did that, it again, carrier sense took a moment. So eventually it figured itself out. I type in no shut, the port would come online. So it was taking some time. It might even be spanning tree protocol taking some time. So if that might be the case with gig 00. But at any rate, the point being here is that when you go to create a VLAN and you apply it to a port, that's going to be you enabling the broadcast domain on that particular port. But if I want to have a IP address inside of that VLAN for doing things like testing from the network to the endpoint, I can create an SPI with an available IP address in that range and then ping that IP. The very first ping that goes out is going to be an ARP lookup because it doesn't know the MAC address. But once it resolves the MAC address through the address resolution protocol, it goes out there and finds it, and then the remainder of the ping works, right? So we know we're in good shape. So that's basically how this comes into play. So in the next video, we're going to take a look at trunk links, and we'll talk about how trunking comes into play with this type of a scenario, and then actually extend VLAN 100 to other ports on other switches and see exactly how that comes into play. So until next time, guys, thank you so much for stopping by and hanging out with me, and I'll catch all of you in the next video.